Section 6.5, Math 60 Palomar, how to solve the equations. The very first problem is y over 3 minus y over 4 equal to 72. So here, you see that what I do first is take, let me get a piece of paper here, sorry. So in a case like this, one of the easy way to do is, they all have, there are three denominators, 1, 3, and 4. So what I do is I multiply every term by 12. So I put a 12 here, and 12 there. So in that case, 3 goes to 12 is 4, 4 goes to 12, 3, and this one would be just 12 times 72. So in that case, I get rid of all the denominators. Again, I have 3 and 4, which is 12. I multiply every term by 12. So in that case, I end up having 4y minus 3y equal to 864. Then the second problem is this. 9w plus 1 over 11 equal 8 over w. So in that case, the common denominator, in fact, is 11w. So I multiply all the terms by 11w. So I put 11w here, 11w here, and 11w there. So in that case, w and w cancel. What is left is just 9 times 11, which is 99. Here, 11 and 11 cancel is w, and here 11 w and w cancel is 88. So in that case, you don't have any more denominator. Then I'll move 99 to the other side. So that would make it minus 11. So these are for those problems. Problem number 3. When you want to solve the equations or fractional equations, before you actually solve the equation, you always have to see what number would make the denominator 0. Like here, what number would make x plus 3 0? That would be negative 3. Because if you put negative 3 here, negative 3 plus 3 is 0. So before you solve the equation, you want to make sure that your final answer should not be negative 3. So at any time, again, you're solving the fractional equations, you want to make sure that you exclude a number that make the denominator equal to 0. Right. So then what I do is I cross multiply. The cross multiplication is this: if you have two equations equal to each other, you cross multiply. So A times D is B times C, or vice versa, or B times C equal to A times. So you take this numerator and multiply by that denominator and times that, and then x plus 3 and x plus 3 both cancel because both are the same. So all is left is x plus 4 equal to 1. The reason, again, the reason I cancel this is, look, you have something like that. Let's say you have 5 times 3, and then you have 1 times 3. Look at this. 3 and 3 cancel, right? Because this is 15 and this is 3. Same thing here. Okay, so then x is what? When I solve the equation, x happened to be negative 3. Although my solution is correct, I don't allow to have that answer. So in that case, I said no solutions. Solution set is 0. So this always works in case you are dealing with fractional equations. Now let's look at this one. This one, before I actually work on the problems, I want to solve it. I see what number would make the denominator 0. There are two numbers. One is 2 and one is -2. So before I solve the problems, I know that I don't want any of these answers. I don't want neither 2 nor -2. So I cross multiply here. Three times x minus 2 is 2 times x plus 2. Then I distribute. It's 3x minus 6 is 2x plus 4. And then I subtract, and I come with the answers, 10. So I would accept 10 because 10 is not any of these two. So as long as you don't have these two answers, you could accept that. This is another one. So before I work on these problems, I kind of see that x cannot be 14 or -14. I cannot accept any of these answers before I work on the problems. One thing is first, x2, what is x2 minus 196? x2 minus 196 is 14 to the power of 2. How do I know? Because I see 14 here. So if I take 14, I use my calculator and raise it to the power of 2, I see is 196. Now remember the formula that if you have difference of two perfect square, is always sum and the difference. See, we are using that here. So x2 minus 14 would be x minus 14 times x plus 14. You could break it using that formula. And then see here, now you have x minus 14, x plus 14. Here you have just x plus 14 and x minus 14. To have the same denominator, the first fraction, it needs x plus 14. So you put x plus 14 here and x plus 14 there. This one, it has x plus 14, but it doesn't have x minus 14. So you put x minus 14 here and x minus 14 here. In that case, they all have the same denominator, so you could cancel. When you cancel, what do you have? You have 3 times x plus 14, which when you distribute that is 3x plus 42 minus 5x. And then you could 5x, you multiply this first and then move it to the left side. So when you distribute this, 5 times x is 5x, but when you move it to the left side, is minus 5x. 5 times -14 is -70, but when you move it to the left, is positive 70. So when you do all this, then x is 16. And you accept it. Why? Because it is not any of these two. Number 6, these problems, again, you have x2 minus 16. x2 minus 16 is x2 minus 4 to the power of 2. So what formula is the difference of two perfect square? a2 minus b2 is a minus b times a plus b. Therefore, x2 minus 4 to the power of 2 is x minus 4 times x plus 4, okay? Which is this. All right, so in that case, before I continue with the problems, I know there are two numbers that would make the denominator 0. One is 4 and one is -4. I don't want any of this, correct? Okay. So now, you could either cross multiply here, and then they both have x minus 4, you cancel that, or you could even cancel it here at the denominator. So then what you have is 2 times x plus 4 equals 16. When I solve it, finally I come up with x equal to 4. Although my solution is correct, I cannot accept this. Why? Because it's one of these two. And the reason is this. When you solve the equation, you always check your answers, right? If you want to check your answer when you take this 4 and substitute here to see if it works or not, when you put 4 here, is 2 over 0 is undefined. That's why we can't even check it, because again, as I said, when you substitute that 4 here, it made 2 over 4 minus 4, or 2 over 0 is undefined. That's why you cannot accept it. What's the requirement for this one? First, I have x2 minus 2x. I factor it like this. So instead of x2 minus 2x, when you factor x out, is x times x minus 2. So what numbers do you exclude here? What number would make the denominator 0? One is x equals 0. The minute you put 0 here, the whole denominator is 0. Then is 2. We cannot accept 2 either, because the minute you put 2 here for x, 2 minus 2 is 0, means the denominator is 0. So you have to exclude these two answers if you come up with it. Okay? So then what I do is this. Look, the common denominator, in fact, is x times x minus 2. I want all the denominator to be x times x minus 2. This one, it needs x. So you put x here. The last one, 4, it doesn't have any denominator. It needs x times x minus 2. So I multiply by that. When you have this, then all the denominator cancel. So what is left is just this. X minus 2 is, when you distribute this, is 4x2 minus 8x. Bring everything to one side. Now, I have to use method of factoring to solve these problems. We need two numbers. When you multiply is 8, and when you add algebraically is negative 9. Those numbers is negative 8 and negative 1. So instead of writing minus 9x, I write minus 8x minus 1x. Now doing that, then I think of group factoring. See? I use the group factoring. I'll take each parenthesis, set it equal to 0, and I come up with these two answers. And one of the answers, I don't accept it. X equal 2, I don't accept it. Look, because it's here, right? But 1 over 4 is okay. So this problem has only one answer. The last problem, number 8. Again, the denominator is just a. I multiply all 3 of them by a. So you put the a here, you put the a here, and you put the a there. So what do you have? You have a minus 4 is 3a. Okay, so look, the only common denominator between 1a and 1 is a. So you multiply this by a, and this by a. Okay, a and a cancel, so you don't have denominator anymore, and that's how to solve it. So that would be end of section 6.5.